Hi students, today we are going to discuss chapter 15 Introduction to Graphs. Chapter 15 Introduction to Graphs. So have you seen graphs in the newspapers, televisions, magazines, books, etc.? The purpose of the graph is to show the numerical facts in a visual form so that they can be understood quickly, easily and clearly. The graphs are visual representations of data collected data collected. Data can also be presented in the form of a table. However, a graphical representation is easier to understand. This is true particular when there is a trend or a comparison to between the comparison to be shown. We have already seen some types of graphs. Let us quickly recall them here. So here we are seeing a bar graph. A bar graph is used to show the comparison among categories. So it may consist two or more parallel vertical or horizontal bars which are in a rectangular shape. The bar graph in figure 15.1 shows that Anu's mathematics marks in three terminal examinations. It helps you to compare the performance easily. She has shown good progress. Now you see, so horizontal bars, first term, second term, third term, how the marks have been increased, progressed. So marks 10, 20, 30, 40. You see the width of the bars. The bars are represent rectangular bars and between the bars width is same. Between the bars width is same. So a bar graph consists of rectangular bars and between the bars the space must be equal. So marks in mathematics and here term examinations, term 1, term 2 and third term 3. This is the bar graph. You observe it clearly, the bar graph, between the rectangular bars, there must be equal space. Here we are seeing one more bar graph. Colors of the cars in a colony. They have been done a survey in a particular colony. What colors of cars those people are having. The survey has been done and that survey has represented in the form of bar graph. You see a red, a blue, green and yellow and one more color, that is last one, metallic gray colors. So these are the colors which have been identified in the survey and the number of cars in the colony, each one unit is equals to 2 cars. 1 unit is equals to 2 cars. Choosing the scale is very important while representing the graphical representation. You can observe clearly between the bars there is an equal gap, equal space. So here on x-axis we are representing the colors, on y-axis we are representing the number of cars. Each 1 unit is equals to 2 cars. The survey has been done in a particular colony. This is how we represent a bar graph. So bar graph can also have a double bars. In figure 15.2 we see this. This graph gives a comparison. This graph gives the comparative account of sales in rupees of various fruits over a 2 days period. We can observe in the figure the comparison. Double bar graph shows that double bar graph, which is easy to understand, comparison between the 2 days of fruit, comparison between the 2 days a period they have observed and the sales have been recorded. Sales how have been recorded. So here we are seeing a double bar graph. See, on x-axis we have the sales in rupees, and on x-axis we have fruits, on y-axis we have sales in rupees. So fruits we have mango, apple, orange, papaya, bananas. So in Monday and Tuesday, you see here the top, which is thickly, which is more shaded, that is on Monday sale, and which is not shaded, that is Tuesday sale. So Monday bananas, mangoes and apple, oranges, papaya, banana. 0, 5, 10, 15, 20, 25, 30, 35, 40 we have chosen. The scale 1 unit is equals to 5, 2 units is equals to 5 fruits here. So taking the scale is important. 2 units is equals to 5. 2 units is equals to 5. Sales in rupees. Sales in rupees. You can clearly observe it. Mango. So on Monday, if you take, there is a 15 between 15 to 20, and the mango on Tuesday, if you take, it is in between 20 to 25 amount in rupees. So sales in kgs, actually it is not the cost, sales in kgs, how many kgs have been done, it's sales in kgs. Sorry, we are taking sales in kgs. Actually I said it's a amount in rupees, but it is in kgs. The graph shows how many fruits have been sold in Monday and Tuesday. The comparison where all the fruits, mango, apple, orange, papaya, bananas, how they have been sold, they recorded and they have been represented the information in double bar graph. So you can clearly you can observe on which day more the people have purchased more. Like mango they are purchasing on Tuesday, and apple they are purchasing on Tuesday only. Oranges they are purchased on Tuesday only more. But whereas papaya it is showing equally, and banana it is showing they purchased banana on Monday. So this how we can compare this by using double bar graph. And even we learned there is another graph which is called a pie graph or a circle graph. A pie graph is used compare the parts of a whole. The circle represents in the whole, circle represents the whole. In figure 15.3 is a pie graph. It shows the percentages of viewers watching the different types of TVs. See, circle pie graph represents the comparison. It represents a pie graph is used to compare the parts of wholes. So we divide into sectors, then we compare. So 10% of informative, and 15% they are observing news, 25% they are observing sports, and 50% they are watching for entertainment. See, this whole circle is divided into sectors. The whole angle is 360 degrees in a circle, that is divided among the given based on the given information. This we have learned in the chapter data handling, how to represent pie chart. Now we see a histogram. A histogram is a bar graph that shows data in intervals. It has adjacent bars over the intervals. That meaning is what? There will not be any gap between the bars. And one more important point, that while representing the bar graphs and all, we can represent horizontally as well as vertically. Based on the convenient we will represent. So while representing a histogram is a bar graph that shows the data in intervals. It has adjacent bars over the intervals. That means no gap between the bars. So here we are seeing the representation of histogram. You can clearly observe it. This histogram. You can clearly observe the histogram. There is no gap between the rectangular bars. So that this information is represented. See, between the intervals, over the intervals, weights in kgs 40 to 45, 45 to 50, 50 to 55, 55 to 60, 60 to 65, and number of persons, that is 4, 12, 13, 6 and 5. What is this? Histogram represents the distribution of weights in kgs of 40% locality. 40% locality. That means, so 4 people are in between 40 to 45, 12 people are, the weights are 40 to 45 to 50, 13 people are 50 to 55, and 6 people are 55 to 60, 5 people are 60 to 65. Now, when they represent, on x-axis we are taking the class intervals, that is weights, on y-axis we are taking the number of persons, how many. And you see here, while representing this, we have some clinked in unbroken. It's a broken line is appearing. Which is broken line? That is nothing but a jogged line. Jogged line has been used along the horizontal line to indicate that we are not showing the numbers between 0 to 40. As we are representing this histogram, so directly we started 40 to 45, 40 to 45, 45 to 50, like this. So before 40, whatever all the numbers are there, that this jogged line, clinked or jogged line represents that there are so many values, but we are not representing all those from 0 to 40. So directly we are starting from 40. This is the jogged line. This is jog line. So clink line, between 0 to 40 there are so many values, but which we are not representing. You can clearly observe it, the histogram, there is no gap between the rectangular bars, and width of the bars must be same. Width of the bars, here it is same, width of the bars. Sometimes width of the bars also we change it based on the, depend upon the information, depend upon the given information. Now we are learning another graph, which is a line graph. A line graph displays the data that changes continuously over a period of time. Changes continuously over a period of time. When when Renu fell sick, her doctor maintained a record of her body temperature taken every 4 hours. It was in the form of a graph shown in figure 15.5 and 15.6. We may call this a time temperature graph. So when she was not well, the doctor recorded her temperature for every 4 hours. See in the table, they mentioned that information. Time 6 a.m. her temperature was 37 degrees. 10 a.m. her temperature was 40 degrees. 2 p.m. her temperature was 38 degrees, and 6 p.m. her temperature was 35 degrees. So the horizontal line usually called x-axis and shown in the timings, as shown the timings which the temperatures were recorded, and what are all the labeled. A vertical line is usually called y-axis. So till now we have learned the horizontal line is called x-axis and the vertical line is called y-axis. See the information, how they record. This is the data what they recorded. Her temperature for every 4 hours they recorded. The doctor recorded 6 a.m. 37, 10 a.m. 40 degrees Celsius, and 2 p.m. 38 degrees Celsius, 6 p.m. 35 degrees Celsius. Here you are seeing two graphs, figure 15.5 and 15.6. In the first one you see they located points 6 a.m., 10 a.m., 2 p.m. and 6 p.m. On y-axis they are using the jog line. Why they are using jog line? You can see here, because the values between 0 to 30 we are not representing. Directly we are using the temperature in degrees Celsius from 30. So each one unit is equals to 1 degree Celsius, 30, next 32, next 34, 36, 38, 40. That means between 30 and 32, 31, 32, 34, 33, 34, 36, 35, between 36 and 38, 37, 38 and 40, 39, 40 and 42, 41. Here on x-axis we have taken 6 a.m., 10 a.m., 2 p.m. and 8 p.m. You see clearly the point how we are located 6 a.m. along with the 6 a.m. if you move where the temperature is 37 degrees Celsius. Along 10 a.m. if you move the temperature is 40 degrees Celsius, located a point. Along 2 p.m. temperature is located at 38 degrees Celsius, put a point. And 6 along 2 p.m. that is 38 degrees, and along 6 p.m. the temperature is 35 degrees Celsius. They located a point. Now if you join these points, first point to the second point to the third point to the fourth, we obtain a line graph. You see clearly, first graph shows how to represent the points, second graph shows how to join the points. This is the line graph. Let us see one example. The given graph in figure 15.8 describes the distance of a car from a city P at different times when it is traveling from city P to Q, which are 350 km apart. Study the graph and answer the following questions. See here, this is the graph. What at time they are started, that is 8 a.m., 9 a.m., 10 a.m., 11 a.m., 12 a.m., 1 p.m., 2 p.m. and 3 p.m. So time represented on x-axis and distance represented on y-axis. So the distance from P in kilometers, 50, 100, 150, 200, 250, 300, 350. Here on the time we represented, because 0 to 8, 0, 6 and 7. So morning earlier that there are times intervals, but we are not representing the other timings. Directly we started 8 a.m. You see here, 8 a.m. they started. By 9 a.m. they reached 50 kilometers. By 10 a.m. they covered 150. By 11 a.m. they covered 200. By 12 p.m. they covered, again they are on the same. And 1 p.m. they covered some distance. By 2 p.m. you see that they covered 350 kilometers. So now the question is, what information is given on the two axes? So on x-axis they have given the time, and on y-axis they have represented distances. From where and when did the car begin its journey? From point P the car began its journey and it started at 8 a.m. How far did the car go in the first 1 hour? So the car go in first 1 hour. How much it is traveled? 50 kilometers. How far did the car go during the second hour and the third hour? During the second hour, you see, from 9 to 10 a.m. it traveled almost 150 kilometers, which is 100 kilometers compared to the first hour. You can see. So that car travels 50 kilometers during the first hour, and 8 a.m. it started from, and 9 a.m. it was 50 kilometers. And third one, the distance covered by the car in second hour 9 a.m. to 10 a.m. is 100 kilometers, that is 150 minus 50. And third hour it is started from 10 a.m. to 11 a.m. 50 kilometers it is traveled, as it is showing 200 kilometers, and before it was 150. Now fourth one, from the answers two questions, third and fourth, we find the speed of the cars was at the same all the time. In fact, the graph illustrates how the speed varied. And in fifth one, we find that the car was 200 kilometers away from city P when the time was 11 a.m. and also at 12 noon. The shown that the car did not travel during this interval 11 a.m. to 12 noon. The horizontal line segment represents the travel during this period, illustrative of this fact. And the last one, the car reached city Q at 2 p.m. as the distance covered at 2 p.m. is exactly 350 kilometers. So in exercise 15.1, the following graph shows the temperatures of a patient in a hospital recorded at every hour. So every hour, 9 a.m., 10 a.m., 11 a.m., 12 p.m., 12 noon, 1 p.m., 2 p.m., 3 p.m. The temperatures were recorded and represented as the line graph. temperatures 34 degrees Celsius, then 35 degrees, between 34 and 35 there is 33 degrees Celsius, and 35 36 between 34 degrees Celsius. So what was the patient's temperature at 1 p.m.? You see, at 1 p.m. what is the temperature of the patient temperature? Clearly you can see that 35 degrees Celsius. When was the patient temperature? 38.5 degrees Celsius. Second question. When was the patient temperature? 38.5 degrees Celsius. 38.5. 35, 36, 37, 38, 39. Here 34, 35. Between 34.5, 35 to 36. Between that 35.5, 36 to 37, 36.5, 37, 38, 37.5, and 38, 39, between 38.5. So when was the temperature? At 12 noon, the patient temperature was 38.5 degrees Celsius. And in third question they are asking, the patient's temperature was the same at the two times during the period given. What are these two timings? So patient temperature is same, that is at 1 p.m. as well as 2 p.m. 1 p.m. and 2 p.m. patient's temperature was, there is no change in that, it was like that. What was the temperature at 1:30 p.m.? At 1:30 p.m. the temperature was same between 1 p.m. and 2 p.m. The temperature is, that is 36.5 degrees Celsius. And during which period did the patient's temperature shown an upward trend? So which interval from 10 p.m. to 11 p.m. only the temperature was shown very high, it is increased like anything. You can see clearly in the data. And see in question number 7, can there be a time temperature graph in the following? Justify your answer. Yeah, as the time increases, speed increases. The first one, even time increases, sometime the speed may decrease, because the beginning it was the time graph, speed, distance, this is time temperature. As the temperature, time increases, temperature increases, and time decreases, temperature, it may decrease, there is a chance. And even in third one you see, same time temperature won't be there like that, so third one is not possible. And fourth one, as time increases, temperature may constant, it may be in the, like sometimes it happens, so third one is not possible. The rest all are time temperature graphs. Now a linear graphs. A line graph contains of bits of line segments joined consecutively. Sometimes the graph may be a whole unbroken line. Such graph is called a linear graph. Linear graph. A line graph consists of bits of line segments joined consecutively. Sometimes the graph may be a whole unbroken line. Such graph is called a linear graph. To draw such a line, when we need to locate some points on the graph sheet, we will now learn how to locate the points and conveniently on the graph sheet. So unbroken line, which is completely a line graph, consists of bits of line segments joined consecutively. Sometimes the graph may be a whole unbroken. Such graphs are called linear graphs. Such graphs are called linear graphs. Let us see exercise 15.1, question number 5, that is the first bit. So here, use the tables below to draw linear graphs. Linear graph. So the number of days a hillside city received a snow in different days. Year 2003, 2005 and 2006, 2004, 5, 6, and the number of days snow received in those years 8 days, and here 2004 10 days, 2005 5 days, 2006 12 days. So years we take on x-axis and number of days we take on y-axis. So here the horizontal line, which we call it as, this is, observe the figure, observe the diagram, observe the representation how we are doing graphically. This is x-axis and the vertical line is called y-axis. See the difference. This is vertical line This is y-axis. And now here 0, where the two axes are meeting, the point is origin 0, equal intervals must be there, 0, then we take here 2, then 4, then 6, 8, 10, 12. 2, 4, 6, 8, 10, 12. Next years we are taking on, this is a number of days. What is this? Number of days. Number of days. And years I am taking on x-axis. This is years. So first year, beginning year, that is 2003, and next 2004, next 2005, next 2006. Observe it, 2003, number of days 8. 2003 and 8, where they both meet. Observe it clearly, 2003 and 8. 2004, 10. 2004, 2003, 8. And 2004, 10. 2005, 5 days it is received. So between 4 and 6. 2005, this is here, between 4 and 5. 2006, it is reached to 12 days. So 2006, here it is 12. So when you join from first point, it's a line segments joining from one to the other, which is continuously brokening, like from here to here, here to here, here to here. This is the representation of linear graphs. Sometimes the whole graph will be unbroken, sometimes only partially it will be unbroken. I hope you understood. Is it clear, students, how to represent? On x-axis we are taking years, on y-axis we are taking number of days, the snowfall received in that particular years, how many days it is. Is it clear? I hope you understood. So rest of the questions, question number 2 and question number 3, which you can finish it in the textbook itself, answering the questions by observing the given line or linear graphs. So in question number 3, in the same graph they have represented, that is two different plants, plant A and plant B, the comparison, plant A, plant B, how they have been grown up. They have been for experiment in a botany, two different plants, plant A, plant B, were grown under similar laboratory conditions. Their heights were measured at the end of each week for 3 weeks. The result as shown in the graph. You see here two graphs, line graphs are there, which to comparison under the same conditions they have grown, but what is the length of the plant when they measured for a week, 3 weeks, every week they were recorded. So it is for the comparison you can. So such type of questions we can finish in the textbook itself to answer by observing the graph and answer the questions. I hope you understood today's discussions, right? Thank you. We'll meet again in the next session. So students, I hope you understood how to represent the graphical representation by using the given information as a line or linear graph. So we will meet again in the next session. Exercise 15.1, fifth question, B bit, two representations comparison is given that you have to represent in the graph sheet. Is it clear? I hope you understood. Thank you. We'll meet again in the next session.